this lesson, we will use the words and or to connect two statements together. We're then going to try to determine how to tackle this new kind of statement. When we connect together two statements either using the word and or the word or, we form what is called a compound statement. The properties of compound statements are a bit different from the other types of statements we've seen so far, so let's look at each case separately. What is your intuition when I say I want steak and potatoes for dinner? What food on my plate would make me happy? Well, I'm logically only going to be happy when I get both steak and potatoes on my plate, not just one or the other. So in essence, using the word and logically means I want both. What does your intuition say when I say I want steak or potatoes for dinner? What food on my plate would make me happy in this case? Well, I'm logically going to be happy when I get steak on my plate, when I get potatoes on my plate, or when I get both steak and potatoes on my plate. The only time I would really be unhappy is if I don't have anything on my plate. And that's pretty much real life anyway. #truth. On this page, I wanted to summarize the big ideas when working with the and or connectors. If we are dealing with a compound statement involving and, the overall statement is true only when both the individual statements are true at the same time. If we are working with a compound statement involving or, the overall statement is true as long as at least one of the individual statements is true. We can summarize these ideas that we just talked about using what's called a truth table. Suppose that A and B represent our individual statements. If A is true and B is true, then the compound statement A and B is also going to be true. However, if one of our statements is false and the other one is true, A and B is going to be false. And finally, if both A and B are false, then our compound statement's going to be false as well. So we call this a truth table for the statement A and B. Let's do the same for the OR connector. If A and B again represent our individual statements, if both A and B are true, then A or B is going to be true. If one or the other statement is true, then A or B is also going to be true. The only time that A or B is going to be false is if both of our individual statements are false. This is what we call a truth table for A or B. Great, so let's practice with a few more examples. Our next compound statement is 2 plus 3 equals 6, and a rectangle is a quadrilateral. Do you believe this compound statement to be true or false? First, let's look at each individual statement. How do you feel about 2 plus 3 is equal to 6? That's false, right? All right, moving on to the next. Is a rectangle a quadrilateral? Yes, it is. See our lessons on counterexamples if you need a reminder. Since we're working with the AND connector, the only way our compound statement will be true is if both individual statements are true. Because one of them is false, we know our overall compound statement must also be false. Let's contrast our last example with this compound statement. 2 plus 3 equals to 6, or a rectangle is a quadrilateral. How does our process change if we use the word or? First, let's look at each individual statement. We already know that 2 plus 3 equals 6 is false, and that a rectangle is a quadrilateral is true. Since we are using an OR connector, our compound statement will be true provided at least one of the individual statements is true. So we conclude our compound statement is true, despite the fact that 2 plus 3 is not equal to 6. Next, let's try to determine how to negate a compound statement. Looking at the statement, you are either rich or happy. Let's assume that we believe this statement. We are content in life if we are either rich or we're happy, or both. When would we not be content? Well, if we are not rich but we are happy, this is okay. If we are not happy but we're rich, this is also okay. So the only way we would not be content is if we were both not rich and not happy. So the negated statement is you are not rich and not happy. Would you be able to summarize how we got the negated statement? Next, let's look at the statement you are rich and happy. And let's assume that we believe this statement. We are content in life if we are both rich and happy. When would we not be content? Well, if we are not rich but we are happy, this is not good. If we're not happy but we're rich, this is also not good. And if we're not rich and not happy, well, this is doubly no good. So to cover all the possibilities, we would use the following statement. You are not rich or not happy. Would you be able to summarize how we got our negated statement? To quickly summarize, if we want to negate a compound statement containing an AND connector, we must use an OR connector, as well as negate each individual statement. And if we want to negate a compound statement containing an OR connector, we must use an AND connector, as well as negate each individual statement. So how would we negate a king is a queen and 3 is a prime number? Well, I would probably start by negating each individual statement first. A king is not a queen. 3 is not a prime number. What connector do we need? Here we would use an OR connector. A king is not a queen, or 3 is not a prime number. That would be the negation of our original compound statement. How would we negate a pentagon has 5 sides, or all dogs wear funny hats? Again, I would probably start by negating each individual statement first. A pentagon doesn't have 5 sides. Notice here that we have a universal quantifier. If you need to review how to negate a UQ, take a peek at that lesson again. First, we're going to replace all, our universal quantifier, with an existential quantifier, like there exists. Next, we need to somehow bring in the word not. There exists a dog that doesn't wear a funny hat should do the trick. Okay, now let's go back to our original compound statement. What connector do we need for our negation? Since our original statement had OR, our negation is going to use the word AND. All right, my little epsilons, stay positive.